Now, let's look at another related race problem. This one involves a triangle and distance, so we'll carefully set up the geometry. First, let's try to understand the problem. An airplane is flying horizontally at a constant elevation of 4,000 feet. So the distance between the airplane and the ground is 4,000 feet. A man is standing 3,000 feet away from the base of the tower. So this is the man, this is the tower. The distance from the man to the tower is 3,000 feet. The airplane is flying horizontally away from the man at the rate of 600 feet per second. So the airplane is flying in this direction with the rate of positive 600 feet per second. We want to find how fast the distance between the man and the plane is increasing when the plane passes over the tower. Let's pause and think. What is changing? What are we given? And what are we trying to find? This is where the man is, and this is where the tower is. The distance from the man to the tower is 3,000 feet. The plane is flying above the man and the tower with the elevation of 4,000 feet. And the airplane is flying in this direction. So let's assuming that the plane starts here and is flying in this direction. When the airplane gets here, we can form a triangle. In this triangle, this distance is 4,000. This distance is not 3,000. And this distance is something. When the plane gets here, we can form another triangle. In this triangle, this distance is 4,000. This distance is different. And this distance is something else. When the plane gets here, this distance is 4,000. This distance is 3,000. And this distance is something. So in this triangle, 4,000 does not change. It's a constant. The horizontal distance x changes. And the distance from the man to the airplane also changes. So let's define our variables. I let x be the horizontal distance from the man to the point directly below the airplane. So x is not just the distance from the man to the tower. X is the distance from the man to the point that is directly below the airplane. So if the airplane is right here, X is this distance. If the airplane is right here, right above the tower, then X is 3,000. If the airplane is right here, then X is this. I let S be the distance from the man to the airplane, which is from here to here. This distance also changes as the airplane moves. Step 2. Let's identify the given information. We're told that the plane is 4,000 feet above the ground. And the plane is flying horizontally at the rate of 600 feet per second. So this is the rate of change of the horizontal distance, which is the rate of change of x, which is dx dt. Notice this is positive. That's because the plane is moving away from the man, so the distance is increasing. Step 3. What are we finding? We want to find the rate of change of the distance between the man and the plane. Here's the man, here's the plane. The distance from the man to the plane is s, and we want to find the rate of change of s, which is ds over dt. Step 4, we want to write an equation that relates s and x. We want an equation that includes both of these variables, and we also know the height is 4,000, so we'll use the Pythagorean theorem. S squared equals x squared plus 4,000 squared. S and x change as the airplane moves. 4,000 is a constant. And remember, do not plug in values before differentiating. So right after you form an equation, you need to differentiate both sides of this equation. To find the derivative of s squared, we'll use the chain rule. The outside function is the power function, so we bring it down. We have 2s multiplying by the derivative of s. To find the derivative of x squared plus 4,000 squared, we'll find the derivative of x squared plus the derivative of 4,000 squared. To find the derivative of x squared, we also use a chain rule. The outer function is the power function, so we bring the 2 down. We have 2x times the derivative of x. The derivative of 4,000 squared is 0. Now we can plug in values. We want to find the rate of change of the distance between the man and the airplane when the plane passes over the radar tower. So we want to find ds dt at the moment the airplane is right above the tower. When the airplane is right above the tower, x is 3,000. Again, x is not always 3,000. X is only 3,000 when the airplane is at this spot. And dx dt is 600 feet per second. To find ds over dt, I need to have x, dx over dt, and s. At the moment when the plane is over the tower, my x is 3,000, dx over dt is 600. I still need s. Again, at the moment when the airplane is right above the tower, this distance is 3,000. This distance is 4,000. To find this distance, I need to use the Pythagorean theorem. S squared equals 3,000 squared plus 4,000 squared. and S is 5,000. Now, I'm ready to plug in the values. I will replace S with 5,000, replace X with 3,000, replace dx dt with 600. Two times 3,000 times 600 is 3,600,000. And 2 times 5,000 is 10,000. Now, I divide both sides by 10,000. 3,600,000 divided by 10,000 is 360. ds dt is the rate of change of the distance from the man and the airplane. That is positive 360. That means the distance between the man and the airplane is increasing at the rate of 360 feet per second.